Hello everyone. Today let's solve the problem number 145 binary tree post order traversal. We have already solved the problem of the this one binary tree in order traversal as well as the pre-order traversal, right? Today let's solve the problem number 145 binary tree post order traversal, right? So what the question states here, we are given the root of a binary tree. We have to return the post order traversal of its nodes values, right? So here we have the example one here, nothing but root. We have been given 1 null 2 3. We have been given 1 null 2 3, right? So just give me a second, 1 second here, 1 second. Yeah, so 1 null 2 3 we have, see here, 1 null 2 and then 3, the final node. So we have to go with the return by making use of this one, and which follows the order post order. So we have to go with the post order traversal right here. So post order traversal, basically what happens here, it follows the order left, right and then root, right? Left, right and then root. So this follows the order left, right and then root, right? So we know this one. So we have already discussed about the pre-order as well as the in order. Today we are going with the post order, right? So we are going with the post order here. This follows the order left, right and root. Just keep this in mind, right? So here we have to consider this one first. Initially itself we have the null here, we have null here, right? So yeah, we have to consider the left, right? So here we have null here, so we'll not considering this one. So before considering the right, we have left for this one, right? So we have left node for the 2, so we will be considering this one first, followed by the 2 here, then we'll go for the node, nothing but here in this case it would be 3 2 1. So this is the post order traversal. Basically we have got the output 3 to 1, right? So for the input 1 null 2 3, let's come with the second example here. So here, just give me a second. We have 1, 2 and 3. This is fine. 4, 5 and here null twice. Yeah, sorry, null 6. Sorry. We have yeah, here we have this one, right? Null 8. So I forgot this one. Null 8. Then uh yeah, then we don't have anything here. This one we will be considering null null. Then 6 7 9. Then we have 6 7 9. This is fine. So the output that we need to get here is, first we'll consider left. First we have to consider this one. This follows left, right and then root, right? So the post order traversal I'm speaking of. So this has to be, initially we have to consider 4. 4 is the last, right? So let's ignore this one. So 4, then we have to go with 6. This one we are considering for the 2. So for the right, so we have the left node for the 5, so we'll be considering 6. Then we will go with the 7. So because this is the first right, 6 7, then 5 we have, then 5 we have, then we will be considering 2, then we will be considering 2. 4 6 7 5 2 for this side, 4 6 7 5 2 for this side, right? So then we will be going, we'll be considering the right side. Right side, the left node we have, first left node we have uh, is 9. First we'll consider 9. Right node we don't have, so we'll consider 8. 8, right? So then this one we have 3 and then finally we have 1, nothing but 9 8 3 1 right side, right? So it will be 4 6 7 5 2 9 8 3 1. So this is how we got the output. So this is of the post order, basically post order traversal. So 4 6 7 5 2 9 8 3 1, right? So this is of the order left, right and then root. Just remember this one, right? So I hope this part is completely clear, man. Now let's discuss the approach first. So here let's consider the first example. Let's consider the first example here. Just give me a second. In the question, before discussing the first this one approach, so they have asked us to go with the this one iterative solution. So here they have mentioned in the follow-up, recursive solution is trivial, could you do it iteratively? So let's solve this one with the stack, rather than going with the recursion. Let's go with the stack for this one, right? Stack and this one iteration, basically iterative stack approach. in simple terms, right? So here let's do one thing. Let's discuss the approach first, man. So here we have 1, null, 2 and 3, right? First what we will do, we have to go left, right and root, right? First we will start with 1 first. So just give me a second here, 1 second. So yeah, let me scroll this one. Yeah, we'll start with 1. So this one will start with 1 and we will push this one to the stack. So as I've said, we will be making use of the stacks. They have asked us to solve this one iteratively, right? So we'll be going with the iterative approach basically. So first we will consider 1 and we'll push this one to the stack. Then we will go right. We are going with the stack. Don't get confused, right? Order is of the uh, order basically is left, right, and this one left, right, and what do we call root, right? So but we are making use of the stack. Basically stack goes with the this one LIFO. Stack goes with the LIFO concept, means last in first out, right? Last in first out. So next we will go with the right, nothing but here this one 2 we have, right? So we will go right to 2 and we will push that one to the stack. Now we have 2, we will push this one to the stack as well, right? So now we'll go to the left. Now we will go to the left of 2, not left of 1, left of 2, nothing but we have 3. We will push this one to the stack as well. We will push 3 to the stack as well. Now what we will do, we will now no left or right of 3. So here, right, we don't have any left or right, right? So we don't have leaf node at all for 3, right? So we will add 3 to the result. The final one we had is 3. We'll add 3 to the result. We will add 3 to the result. So next we will be back with the 2. So we are back with 2. Right, so we have the previous value is 2. Now we will add this one to the result, and then finally if the previous number is 1, we will be adding this one to the result as well. This would be 3 to 1. This would be 3 to 1. The final result is 3 to 1 respectively. The final result is 3 to 1 respectively. Right here, the output that we got here is 3 to 1. Right, so the output that we got here is 3, 2 and 1. Right, so the output that we got here is equivalent to the output that they have given for the example 1 in the question. The output that we got here is equivalent to the output that they have mentioned for the example 1, right? So I hope the approach is completely clear, man. I hope the approach is completely clear. Now, as we are completely familiar with the approach, let's do one thing. Let's discuss the complexities and then let's write the code. So what would be the time complexity here? The time complexity would be big O of n. We are making use of the stack data structure, right? So we are going with the iterative iterative stacks basically. So here we will be visiting each node exactly once accordingly with the approach, right? So we will be visiting each node exactly once as we are going with the iteration or iterative approach. So the overall time complexity would be big O of n. So what would be the space complexity here? The space complexity would be big O of n as well, because we are making use of the stack, or we will be making use of the stack and the output list in the worst case. We will be considering the stack and output list entirely in the worst case. That is nothing but for the skewed tree. We have to in the we are considering for the this one worst case, right? So we'll be considering the skewed tree. So the overall space complexity would be big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n for both, basically time complexity and the space complexity, right? I hope the complexities part is completely clear along with the approach. As we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So here let's do one thing. The first step here would be the linked list will be going with a linked list. So linked list allows us to add the this one, add first efficiently, right? So let's see, let's make use of the linked list here. Just give me a second here. I can write in this way. So this will be linked list of integer. So let me consider the variable name result here. This would be new linked list. This is fine. New linked list. This is fine. So the next step would be the base case. If the root is null, then we have to return a result directly, nothing but the empty array. So this one will be if root equals null, then what we will do, we have to return we have to return null we have to return sorry, we have to return the result empty array. So this is fine. So the next step is, as we had discussed in the approach, we will be making use of the stack just to simulate the recursion. Means we are not going with a recursion, we'll be simulating the recursion by making use of the stack. Instead of the recursion, we will be going with the iteration here. So I'll just go with stack here, tree node, this is fine, stack. So this will be new stack. This is fine. This is just the what do you call syntax basically. Next, let's start with the root initially. As per the approach, we have to start with the root, right? So I'll just go with stack dot push of this one root. This is fine. So the next step is, let's move on with the while condition. So here this would be while of stack dot is empty. Stack dot is empty. So this within the while loop, what we'll do, we'll pop the top node first, right? So for that one, I'll just go with a tree node equals stack dot pop here. This is fine. So we are just popping the top node here. After this step, we will add the root value at the beginning to reverse this one later. So I can just write this one or articulate in the form of code in this way. I'll just give result dot add. So add first. So we have made use of the add first, right? So just give me a second here. So yeah, let's go with the add first here. This one will be value of the node, nothing but we can write in this way, node dot val, right, in the form of code. So we are just adding the root value at the beginning to reverse this one later. So next, let's do one thing. What if the left value of the node is not equal to null? Only when the left part of the node value is not equal to null, then only we have to push the left child first, right? For let's articulate the same thing in the form of code. This one node dot left, if it is not equal to null, then within the if condition, I'll just go with stack dot push of this one will be node dot left. This is fine, node dot left. So let's come with the let's move on with the next step here. This would be if node dot right not equal to null, then so we will push the right child later, so it's processed first, because we are making use of the stack and this follows the LIFO. Stack follows the LIFO. That is the reason we will be pushing right child later, so it is processed first. Again, I'm stressing on it, don't get confused here. We will be processing the right child one after this one after one. We have considered two, nothing but yeah, two. So but the this one post order traversal goes with a left, right, and then root or the node, right? So here, instead of considering this one left, we are going with the right one. After one, we are considering two, right? Why we had considered two? Because we are going with the stack. Basically, stack follows LIFO, means we are pushing right child later, so it is processed first, right? So here we can write this one in this way: node dot right, if it is not equal to null, then I can just go with stack dot push of this one node dot right, stack dot push of node dot right. So this one, let me come out of this one entirely. So final step is we have to go with the final reversed post order list, nothing but that will be stored in the result variable, right? So we have made use of the result variable here. This one, sorry, this one, yeah. So let me do one thing. Let me go with return result. Let me go with return result here. Let me format the code once and let me hit the run button, right? So I hope this works, man. Let's see. So we have the compile error here. T has to be capital here. So here this has to be T. This is fine. Yeah, now you can clearly see here the sample test cases are getting passed. Means let's see whether this works for all the test cases or not. Let me hit the submit button first. So yeah, you can clearly see here all the test cases are getting passed, means the code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the this one, what do we call, approach and the complexities, right? So we have solved the problem on post order traversal, pre-order traversal and in-order traversal. So I hope these concepts are completely clear. Uh, Three are of the different order, right? If you remember, right? One is, one follows the order, this one, what do we call, root, left and right. Another follows left node as well as right. So the finally post order follows the order, this one, what do you call, um, left, right and root, left, right and root. So these are three different traversals. So we have to keep this in mind. This is very important concept when it comes to trees, right? So in the trees we have to concentrate only some of the things. I'll tell. One is the concept of this one, what do we call, uh, pre-order, post-order, and this one, what do we call, uh, in order. These three things and different type of trees, right? So that we need to consider: binary tree, binary search tree, this were n-ary tree and ternary tree. This we have to consider. I mean, yeah, this we have to concentrate on. And another stuff is this one. We can either solve the tree problems using BFS or DFS. We can just go with BFS or the DFS with recursion. Usually, if we make use of the recursion and the to solve the trees problem, it will be very easier basically to solve the trees problem with the by making use of recursion. So just keep this in mind. And every tree problem, it can be solved either by DFS or the BFS, right? So usually we'll be making use of the recursion, right? Usually we'll be making use of the recursion. Here, as they have strictly mentioned here in the question, that recursive solution is trivial and can you do it iteratively? That is the reason I have made use of the stack and I have went with the iterative stack approach rather than the recursion. Usually, if we make use of the recursion, this one, what do we call? We can, the code will be less and also it will be very easier to understand basically if we make use of the recursion to solve the tree problems. It can be either solved by BFS or the DFS as well, right? So I hope this part is completely clear, man, right? Just keep these three things in mind, right? Also one more thing, nothing, just go with the types of trees as well. Be binary tree, binary search tree, n-ary tree, as well as the this one, ternary tree. So just go with the types of the trees. There are different trees as well, AVL trees. You can just go with the this one, other trees as well. So these three are very important basically: binary tree, binary search tree, this one, n-ary and ternary trees. So just try to understand this concept before solving the tree problem. So for now, I hope the solution part is completely clear, right? For now, this is it. Thanks for watching, guys.